Every single night, after the sun sets, an event of almost unimaginable scale happens in the dark, silent depths of our oceans. Countless small sea creatures, from tiny krill and squid to a huge variety of fish, start a journey up from the deep sea. The goal? To feed at the surface under the cover of darkness. This is Diel vertical migration. In terms of sheer biomass, it's the largest migration of animals on our planet. It's a rhythmic, nightly pulse that moves through every ocean, a massive commute driven by the most basic need of all, to eat. But this story isn't about the trip up. It's about the journey back down. Because every single morning, this largest migration on Earth becomes a death trap. Billions of creatures flee the coming light, but they aren't escaping to safety. They're swimming directly into the hunting grounds of the planet's most patient and specialized predators. The daily journey for survival turns into a frantic, desperate race against the dawn, transforming the ocean's twilight into a buffet for the abyss. So, what is it that turns this predictable, daily event into the most dangerous commute on Earth? Imagine an entire ecosystem playing a massive, global game of hide and seek. That's pretty much what Diel vertical migration is. The rules are simple. During the day, the sunlit surface waters, the epipelagic zone, are a terrible place for small, vulnerable animals. Visual predators are everywhere, and there's nowhere to hide. So, these creatures retreat to the relative safety of the deep, into a world of endless twilight hundreds, or even thousands, of meters below. But here's the catch: the sunny surface is where all the food is. Phytoplankton, the microscopic plants of the sea, are the foundation of the entire marine food web, and they thrive up there. To survive, the deep sea dwellers have to come up to eat. And the only safe time to do that is at night, when the darkness can hide them from predators. So, as dusk falls, a great upward migration begins. Trillions of organisms, a living wave of squid, fish, jellies, and crustaceans, rise from the depths. This moving mass is so incredibly dense that when sonar was invented during World War II, operators were baffled by what they thought was the seafloor itself moving up and down each day. They gave it a name, the deep scattering layer, and it is, without a doubt, the largest synchronized movement of life on the planet. They feast all night in the rich surface waters, but as the first hints of dawn appear, the game changes. The journey down isn't a casual commute home, it's a desperate race for your life. The basic trade-off for these migrating animals is simple: eat, but don't get eaten. Going up at night is their solution for finding food. Going down at dawn is their solution for avoiding predators. But that trip down is filled with a unique and terrible danger. As the sun rises, its rays pierce the ocean surface, and light starts to filter down into the water column. For the migrating animals, this returning light is a ticking clock. They have to get away from the surface before they're exposed to the daytime hunters that patrol the upper ocean. But in their rush back to the deep, they have to pass through a very specific area, the mesopelagic zone, better known as the twilight zone. This is the ocean layer between 200 and 1,000 meters deep, where sunlight fades from a dim glow to nothing. And it's here, in the hazy, low light of dawn, that the death trap is sprung. The twilight zone becomes a gauntlet. It's not the bright, open hunting ground of the surface, nor is it the total blackness of the abyss. It's an in-between world, a realm of shadows and silhouettes. And this strange environment gives a lethal advantage to a very specific kind of predator, one that has perfected the art of hunting in dim, transitional light. The twilight zone at dawn is the perfect ambush spot. As the hordes of migrating animals pour down from the surface, they form a concentrated, moving river of food. The faint, downwelling sunlight from above creates perfect silhouettes, backlighting the prey for any predator looking up from below. Meanwhile, the light is still too dim for the prey to clearly see the dangers lurking in the gloom. It's a one-way mirror, and the migrating animals are on the wrong side of the glass. This is where the masters of low-light hunting thrive. Predators like large tuna, billfish, and especially certain species of sharks, are perfectly adapted to exploit this daily event. They don't need bright daylight. In fact, they're better without it. They patrol the twilight zone, waiting patiently for the morning rush hour. For them, the frantic descent of billions of creatures isn't chaos. It's a predictable, reliable food delivery service. They aren't just opportunistic feeders, they are specialists of the dawn, timing their hunts to perfectly match this mass migration. They are the toll collectors at the gate between night and day, and the price is steep. Among the Twilight Zone predators, sharks might be the most perfectly equipped for the dawn ambush. Many deep-water shark species have evolved enormous, highly sensitive eyes, often with a green tint, that are exceptional at gathering the few photons of light in this dim world. Their retinas are packed with rods, the photoreceptor cells responsible for low-light vision. To our eyes, the twilight zone is nearly pitch black, but to a deep-sea shark, it's a perfectly lit hunting ground. But their eyes are only part of the story. What makes these sharks the ultimate ambush predators is their whole array of other senses. They can hear the low-frequency vibrations of struggling prey from over a kilometer away. They can smell tiny amounts of chemicals in the water, basically tasting a meal from a distance. And most incredible of all, they have a sixth sense, electroreception. A network of special pores on their snouts, called the ampullae of Lorenzini, can detect the faint electrical fields generated by the muscle contractions of any living animal. This means a shark doesn't even need to see its prey. It can sense a fish hiding in the gloom just by detecting its heartbeat. This allows them to strike with terrifying precision in near total darkness, ambushing targets before they even know what hit them. And they're not alone. Other predators use different but equally deadly tactics. Swordfish, with their own massive eyes, have specialized organs that warm their eyes and brain, allowing them to see more clearly and think faster in the cold, deep water. Some bioluminescent sharks are even thought to use their own light for camouflage, a technique called counter-illumination, where a soft glow on their belly breaks up their silhouette against the brighter water above. It's a world of sensory superpowers, where predators have evolved to turn the challenges of the deep into a deadly advantage. It's truly incredible to think about the complex web of adaptations that governs life and death in the deep sea. If you're finding this hidden world as fascinating as we do, and you want to see more stories from the parts of our planet we rarely get to see, consider subscribing to the channel. It helps us continue to bring these mysteries to light. Of course, the prey aren't helpless. Their migration is itself a finely tuned survival strategy, refined over millions of years of being hunted. And recent research has revealed just how sophisticated this daily race can be. It's not just a mindless stampede for the depths. There's a strategy to it. Studies have shown that the smallest, most vulnerable animals, and the fastest swimmers, are the first to head down as dawn approaches. They leave early to minimize their time in the dangerous, brightening waters. The larger, more noticeable animals tend to hang around the surface longer, descending later. They're taking a calculated risk, weighing the need for one last bite of food against the growing danger of being seen. Every morning is a new gamble. This isn't just an instinctual flight from light, it's a complex, dynamic process involving millions of individual decisions that determine who lives and who becomes breakfast. As the survivors of the Dawn Gauntlet finally reach the safety of the deep, they carry more than just their lives with them. They carry carbon. By feeding on phytoplankton at the surface, these animals consume vast amounts of carbon. When they return to the deep, they transport that carbon with them. When they breathe, excrete waste, or eventually die, a portion of that carbon gets released into the deep ocean, where it can be trapped for centuries, unable to re-enter the atmosphere. This process, known as the biological carbon pump, plays a vital role in regulating Earth's climate. By some estimates, this daily migration is responsible for transporting a huge portion of the carbon that sinks from the surface into the deep sea. The life and death struggle that plays out every dawn in the twilight zone isn't just a local drama, it's a critical mechanism in a global system that affects every single one of us. The largest migration on Earth may be a death trap for many, but it is also a life support system for the entire planet, a constant, powerful reminder of the profound and often brutal interconnectedness of the ocean's hidden world.